Okay, thank you. So I'm going to have a little bit of a demo that goes along with this talk. So if you want to check that out, the URL is already on the screen there for that demo. So when we build modern applications in a lot of new frameworks in React, in Angular, we tend to think of our app in terms of components. We use the components as the unit of separation, the unit of cohesion in our applications. And those components are then responsible for the rendering of our application, the behavior of our application, what state we track, and of course, the data fetching. So let's consider a kind of social networking type app. You can post stories to it, and you can vote up those stories. And then the stories appear in the order that they're voted in. Let's consider what the data flow might look like for that app when it's initially rendering. So in the simplest case, our app requests a list of stories to display, and the server returns that list of stories, along with all of the data needed to render those stories to the page. Now, this is the kind of simple RESTful idea that we see a lot of. But in fact, REST actually kind of originally suggests a greater separation than this. Really, we should request not the actual list of stories, but the list of story IDs. It should be up to the story component to request the data it needs to render the story. So if we start again, and we include the actual story components this time, so our app is going to render a list of story components, and each story component needs to fetch some data to render the individual story. So this time, our app requests a list of story IDs. The server returns a list of story IDs. Each individual story makes a separate request to get a story by ID, and then the server returns the data needed to render each story. Now, clearly, this is going to be terrible for performance. No one wants their app to be making n+1 requests in order to render n items. But I want you to bear with me on that. I promise we'll talk a little bit about the performance of this later and find some ways to perhaps lessen the impact of that. What I want to focus on for now is the fact that this is actually a really nice way of writing our application. It means that if you add a field to what's needed to render a given story, then the only component you might need to change is the story component. You don't need to think about the rendering of the stories in your app component. So let's start looking at some code. What does that look like to request that list of stories in React? So we're going to start by tracking two pieces of state. Whether we've finished loading the list of stories and what that list of stories is. Part of the reason we've got this model of tracking state is that our app has to render something straight away. It's this kind of synchronous process rendering. You have to render something to the screen, even if you haven't yet got all your data. Once this component's been mounted, that's the point where it has the opportunity to start fetching some data. So in this is kind of a lifecycle hook. I don't know how many people are familiar with React. Quick show of hands. So about half, I guess, third to a half of the audience. So React has these lifecycle methods. If you implement certain methods with certain names, they get called at particular points in the lifecycle of your component. So in this case, component did mount gets called once the component has been mounted into the document. So it's the perfect point to request data. So in that lifecycle method, we make an API request to the server, and we request this list of stories this list of story IDs. And then we update the component's state once we get that list of stories back. Our render method is just a function that returns components based on the state of the component. It returns child components based on the state of the current component. So in the case where we're loading, we return some kind of loading indicator, a spinner. If we're not loading, then we can simply render the list of stories. So in this case, we're taking each story and we're mapping it onto some story component, which we give the ID of the story. It's then up to the story component to render the actual story itself. Our story component looks very similar to our app component, bearing in mind that I'm ignoring the details of rendering a kind of nice, pretty UI here. So again, in the state, we store the loading property, whether it's loading, and we store the actual data that we're going to eventually load. Once this component gets mounted, we make a request to the server to load the data we need, and then we update the state. When we come to render, again, if it's currently loading, we render some kind of loading spinner, some kind of loading indicator. And if data has been loaded, then we can render the story itself. Again, I'm not interested in exactly how we render it, what we render here. The thing I want you to focus on is the way that the data is loaded and the flow of the state. Now, I said this is almost identical to the app, the story in the app. These two components are both fetching data in order to render themselves, which means they look really similar. When we have two things that look almost identical in our application, in our code, we tend to want to find some way to combine them into one and make code reusable. So if we look at the part of this code that's the same, it's actually most of it. There are really only two things that change between different components that have to load and render data. In this case, it's what data do we fetch? So that's just the URL of the data we want to fetch. And what component are we ultimately rendering once the loading has finished? We're actually loading the same, we're rendering the same loading indicator regardless of the eventual component. So it's really only once the data has loaded that this differs. So how do we share functionality between components in a system like React? We use higher-order components. And higher-order components is a concept that is common to lots of component-based architectures. And the idea is that you take some component and then you wrap it in another component. And the wrapping component is reusable, so you can swap the inner component. So if we take this blue blob and we imagine that's our app component, we can wrap it in this orange blob that takes over the job of fetching the data. The blue blob renders the content, the orange one fetches the data. We can take a different component. Sorry, those are quite similar colors. This is sort of a purple blob. And we wrap that in the same outer component to do the same job, to fetch the data. Now, we're JavaScript developers, so the way that we share code is using functions. So in this case, we're going to have a function. I'm going to call it withData, and this is our higher-order component. And it's going to take an argument for each of the bits of our component that change between the different between the different implementations. So in this case, it's going to take a function called getURL, and that's going to return the URL of the data we want to fetch. And it's going to take the actual concrete component, which is going to be the rendering logic for the story or for the list of stories in the whole app. So then we add this class data fetching, and we return that. And this looks exactly like the React components that we started with. It looks exactly like the app component and the story component we had at the beginning. All that we've done is taken the bits that change between those two and replaced them with things that are arguments to our function. So in the case of getURL there, the fact is that the URL could depend on the properties. In the example of the app, it doesn't. It's just a static URL, API/stories is what we loaded. But in the case of an individual story, that URL needs to include the story ID, hence why that's a function. And then the component there, we just render the component. We pass through any properties that we were given, but we add an extra property, data, which is the data that's been loaded to render that individual component. We're taking care of the loading state entirely within this higher order component. So our actual kind of implementations, our user land components, don't need to think about a loading state. As far as they're concerned, the data has already loaded straight away. As soon as that component is being rendered, the data's loaded. Let's have a look at how we use this. So if we were in a perfect world where all of the data was already loaded up front, then our app component could just look like this. A simple component that takes a list of story IDs as its data property and renders them straight away. And we can write that component and simply use a component like with data to wrap that into a container that can take care of fetching the data as well as rendering the end content. Now we have much less duplication between our app and our story. Our story just takes care of rendering the story. It can assume that the data is already fetched. Then we simply wrap it in the with data higher order component, which has a function for getting the URL that we need to load. That's stories/story ID, and it takes the component to render. So we've separated out the data loading from the rendering and behavior of our individual components. And by doing so, we've made our code much more declarative. We're now just declaring the data we need as part of the construction of this component, rather than having to manually go through the process of setting different states in our application. So one of the advantages of getting all of your data fetching logic into this one place is that you can take care of common concerns just the once. So every time you fetch data, there's a chance that it could error. Even if your code is perfect, there's a chance that there's some network issue and the data fails to load. There's a chance that it times out, that it's just slow. There's a chance that that data's already been requested somewhere else, and you might already have it and not need to fetch it again. So by having all of your data fetching logic in this one place, it gives you one place where you need to implement error handling, loading states, retries, caching, batching requests. All of that kind of thing can be implemented once for your entire application, which saves you from this thing where you think, is it really worth implementing error handling? Most of my users are on nice, fast internet connections like me, I'm sure. I'm sure it'll be fine. But that's not the case. So the great thing about having this in one place is that you can write that code once. It's always worth writing that code. So let's have a look at the next thing, which is updating. So we've talked about fetching data. Now let's talk about how we update that data, how we handle changes in our application. So really, the updates should come from the story components. When you vote on a story, it should be the story component that handles that vote, that click on the vote button, and sends that to the server. And then the server's going to return the updated story. Now, for performance, ideally, you want the server to return everything that's needed to update the state of your application locally. And so for our application, that would be the order of the stories, as well as the individual story ID. Now, this is where we run into a bit of a problem. Our with data wrapper doesn't have any notion of data changing over time. And it doesn't have any notion of data being in any kind of shared location. There's no way from within the story component to update the order of the stories. That data is separate. So even if we update the with data wrapper to allow the story component to tell the with data wrapper that the data has updated, there's no way to tell that parent of the parent, the app component, that data has also changed. So what we need to do is change fundamentally how our higher order component works, how our with data component works, to bake in this idea that data changes over time. So we're going to change it, so we're not making a static request anymore. We're now subscribing to some feed of data. So I've created this new component. I'm going to call it the Datastore, and that's going to give me a central location to manage all of the data in my application. And now, instead of directly requesting data from the server, my component subscribes to some query on this data store, on this central data store. Whenever the data store sends me an update, I update the state of this component. So instead of getting that update once, it might get it multiple times. I know it's going to get it at least once. It's at least going to get that initial data, but then as it changes over time, it might get called multiple times. If we're subscribing to anything in React, we also need to remember to unsubscribe, because this component might get removed from the tree, removed from the document in the future, and we don't want it to carry on receiving updates indefinitely. So we add another lifecycle hook for when the component is unmounted, and at that point we unsubscribe. The other thing we actually need to think about is that the properties of this component might change over time, even without the component being mounted and unmounted. So that query could change over time. That query isn't necessarily static. So to handle that, we've now got 3 lifecycle methods. And I've defined a helper here called subscribe. So subscribe, given the properties, fetches the query and subscribes us to the results of that query and sets the unsubscribe property appropriately. When the component mounts, we subscribe with the initial properties. We handle this component will receive props lifecycle method. So that's called whenever the properties are about to update. And in that method, we check whether the query has changed. So we get the old query, which is that get query this.props. We get the new query, get query new props. And if those are not equal, then we know that we need to unsubscribe from the old data and subscribe to the new data. And if this component is ever removed from the document, removed from that tree, and we're no longer displaying it, we need to unsubscribe. So I've introduced this new concept called a Datastore. The API of the Datastore looks something like this. It has a method to subscribe to a given query, and that method takes a query and a function, and it will call that function every time the results of that query change. So it'll call that function straight away, even if there's no data loaded, to just say there's no data yet. And then it'll call it again once the data has loaded, to say it's loaded now, here is the data. And then it will call it again any time that that data changes, any time the local cache of that data changes. So there's some implementation of this. I'm going to skip this because I'm going to actually talk about that a bit later. So the other method it has is, the other methods it has are methods for updating. So it has an add story and a vote method. Add story simply sends a story to the server and then updates any of the queries that change as a result of that new story. Vote for a story ID sends that vote to the server and then updates any of the queries that change as a result of the votes changing. So what this means is that data store has the ability to send the request to the server, get the response from the server, and then knows what needs to be updated. It has access to all of the data in the local cache, has the ability to update any of it. So again, I'm going to skip over that. So the responsibilities of the data store are that it merges queries from separate components, which gives us the performance that we needed at the beginning. I said we had a performance issue with making n+1 requests, one for each story ID, plus the list of story IDs. So we're no longer doing that. Our data store can take on the responsibility of seeing that there are lots of requests for story IDs, for stories by ID, and sending one request to the server that says, get me all of the stories with this set of IDs. It can cache the query responses. Again, this is good for performance. It means that if we're rendering the same thing in 2 different parts of our application, we're not going to fetch that same data twice. It can handle updates and merging of changed data. So the great thing about this is that we can keep our application consistent. Even if we're displaying the same data in multiple places in our application, it only exists once in that local cache, in that data store. So we only need to update it in the one place. If you want to make your application kind of real-time, then the data store is a great place to deal with that kind of logic and subscribe to real-time updates from the server using something like WebSockets. And if you want to build in optimistic updates, so this is the idea that we update, like when the vote count, when someone presses on the vote button, we can locally increment the vote count by 1, because we know that's what's going to happen once we've sent the request to the server and got the response back. So we can do that in advance, but it's a little bit tricky. We then have to roll that back again if there's any errors. If anything goes wrong with the server request, we need to roll that back in order to carry on matching what happens on the server. So doing that in this one location, again, really helps to make sure that your app stays consistent. And I'm going to swap to a demo at this point, if this works. Cool. Lots of people have have created posts and voted, so that's obviously working. So I'm currently looking at the bicycle implementation. I don't know which implementations other people are using, but you can go on this page and you can post stories and you can vote on them, and you can also change to any other implementation. So all of the kind of different levels of this I've talked about are available as implementations on here. So let me just put that on. Right. So let's make that a bit bigger. For time. Right. I also need to zoom this. Did that let me zoom? Right. I can't see anything. Right. Sorry. So let's have a look at what that data store would look like then. So for the data store, we keep track of what requests are in flight, what requests we already have some data cached for, and what subscriptions have been registered, so which functions have been subscribed to which queries. So I'm going to start by declaring 3 variables, one for each of those. And then our subscribe function is going to immediately call the callback and pass it 2 arguments, the first being whether the data is loaded or not, and the second being that data if it's loaded. Then it's going to make a call to this fetch query function. Fetch query is going to be responsible for fetching the query and updating any subscriptions if the data hasn't already been fetched. And then finally, it's going to track that subscription, add this function to our list of subscriptions, and return a function to unsubscribe, return a function that removes that subscription. So fetch query then checks that the query is not currently in flight, and then updates which queries are in flight. Can people read that? Is that clear enough? Yeah. It then makes the request to the server. Now, I haven't implemented any kind of batching or retries here or even error handling properly, but that's where you would do this. Once it gets a response from the server, it updates the cache first. It stores the response in the cache, and then it updates any subscriptions, anything that's subscribed to that query. And if the request fails, then it obviously marks that request as no longer being in flight, and again updates the subscriptions. And we could add proper error handling in there, but I haven't done so. Updating the subscriptions is just a case of going through the list of all subscriptions, seeing which ones match the query that's been changed, and calling all of the functions that match that query with both whether the data is loaded and what that data is. So then our add story method calls the appropriate API to add a story. And then once it gets a response from the server, that response includes all of the data needed to update the local cache. So in this case, it includes the list of IDs. Can I make it up? Yeah. So it includes the list of ID. So that API returns just the story that's been added. So we know that it's going to have 0 votes initially, which means we know we're going to add it to the end of the list. So we simply add that ID to the end of the list of story IDs, and then update the cache for that story as well, so that when it gets requested shortly after, it's already in the cache, and we don't have an initial loading ... for no reason. Finally, we update both those subscriptions, so anything that's subscribed to that gets the update. Voting for the story, I've actually implemented optimistic updates here. So if the story that you're voting for is already in the cache, then we update that cache by incrementing the vote count by 1. And we update anything that's subscribed to that story. So that will update the display of the vote count. So if you're using the Datastore example of this, you should see that as soon as you tap on the button to vote for something, the vote count goes up, and then it goes to the server. So there's not that delay while the request happens. Then we make the request. The server returns the list of story IDs, because the order of them might have changed, and the updated story. We put both of those in cache, and then we update things that are subscribed to either of those methods. In the case that there's an error, we then roll back that optimistic update. So if you, click vote and then very quickly disconnect from Wi-Fi, you'll see that the vote goes up, but then back down again once the request fails. Yeah, so that's all of that. So I'm actually, the version I was using there is the version built using Bicycle. So Bicycle is my attempt at solving data fetching in React in a much more generic way. So it's not actually tightly coupled to React. My initial approach was to build something for React, but it turns out that the bulk of this problem is actually a generic one. It applies equally to any framework. So Bicycle consists of two parts. A data store implementation, which is a generic implementation of that data store that lets you subscribe to queries and send updates to the schema. And then it also has a React library which provides ways for you to bind that to your React application. Essentially, it's just an implementation of that higher order with data component that we saw earlier. I have only built it to work with a matching server-side API, so you do have to write your server in Node.js if you want to use Bicycle at the moment. And as far as I'm aware, there's no one using this in production. So this isn't battle-tested production code. Great for your next hobby project. Great if you want simple examples of this to follow to build your own data fetching library. But if you're using it in production, then you're on the cutting edge at least. So let's have a look at some of the code for that then next. How am I doing for time? Have I got enough time? I don't know. So the Bicycle, right. So the server side of Bicycle, just briefly, you have to actually define a schema, and you start with a root, and your root object, each object can have fields, and then your queries are going to select which fields you're interested in. And in this case, I've just defined on the root object a stories field, which is the list of stories. And that just returns an array of story objects, so that's this return type. And the resolve function is the function that gets called as the kind of implementation of that field. And this returns the list of stories. It also defines a mutation, but in this case, I've just defined a kind of no-op refresh mutation, and that allows me to do very crude kind of real-time updates. The story then is implemented primarily as a list of fields, so body is a string, vote is a number, and then here we have the proper list of mutations. So you can create a story which takes a body as a string, and it will call the appropriate API to create that story. You can also vote for a story, which takes an ID, and it will call the appropriate API for that. Now, one of the neat things about Bicycle is it actually keeps a little server-side cache of what data the client has. So without you having to do any work, it will figure out what the minimal amount of data it needs to send to the client is in order for the client to update its cache. So the data going over the wire is always just what's changed and nothing else, and there's no need for you to write anything to do that. So the client for this, have I got the right bit? Yeah, so for the client for this, you define, you create a new instance of the Bicycle client. So that's your, that's if you like your data store there. You can define the behavior for optimistic updates here. So in this case, I've defined a vote optimistic update, where I've said if that story ID is in the cache, then update the votes property of that story ID to be the old votes property +1. And Bicycle will take care of applying that optimistic update and then also rolling it back again if the request fails. Because I want to do a kind of fake real time, I've got this set interval, and I'm calling this refresh, which is just a no-op mutation on the server every 3 seconds. So by telling Bicycle that I'm going to send it an update every 3 seconds, it checks to see if anything's changed. So it's a really crude way of doing refresh, and I intend to build something kind of better and more efficient at some point, but haven't done so yet. And then this provider thing just associates a data store with your tree of React components, which is so that you can do server-side rendering, but you don't really need to worry about that now. So if we look at the app component now, so the app component here, that connect is just like our with data wrapper, except this time the query is an object, and it says that we want the stories field from the root object. And for each of those stories, we want the ID field, plus all of the fields that are needed to render the story component with that field. So the story component is going to expose a list of the fields it needs, and then we'll use that there. And then we're also binding up that add story mutation in this place. So when we submit a new update, we're calling that add story mutation, and that adds the story. I don't want to spend too long on going through this, so I'll leave that there. But the examples are online, so you can have a read through them. I'll tweet out the URL. I think I already have, actually. And like I say, it's in the slides. So if you want to go through those in your own time, please do, and ask any questions you have in the issue tracker on GitHub, and I'll try and answer those. So the other implementation of this that you could choose to use is Relay. Relay is built by Facebook. It's tightly coupled to React at the moment, and it uses a GraphQL endpoint. So there's actually implementations now of GraphQL in loads of different languages. So the odds are there is one in your language of choice. Again, it requires you to define the structure of your code, the schema. But this time, it also requires a lot of detail about what exactly changes in the updates. And this allows it to be much more efficient. So it doesn't have to do the diffing that Bicycle does in order to figure out what the minimum amount of data is to send over the server. And it really efficiently merges queries on the client. So this is a really high-performance implementation of this. But it has a steeper learning curve. So if your application is small, or doesn't need to scale that high, then perhaps consider Bicycle. If you're writing a big kind of production application, then I really recommend you try out Relay. It uses a lot of the same kind of concepts that are in this talk, but it's a very much more complex and higher performance implementation. But the other thing you should really consider still is building your own data store. So the odds are you don't have a lot of the requirements that Relay and Bicycle are attempting to solve. And if you're willing to build your own data store, then it can work with your existing API. There's no need to change the server, which makes it easy to adopt incrementally. And you can make something that's perfectly suited to your needs. So you may not need real-time. You may not need real-time on everything. You may need real-time on specific fields. You might need optimistic updates on some fields, but not others, for example. So you can build something that really works for you. So a couple of conclusions. You should use higher order components for shared logic, particularly in React, but I think really in any kind of component-based system. The best way to share behavior between components is using higher order components. And I think you should use one centralized data store for your entire application. One place stores your data in a normalized form. That means you have one place to update anytime anything changes, and it makes it much easier to keep your application consistent, to keep the state of your application consistent. Thank you.